Hi, I'm Scott Campbell with Solve 3D.
And I'm Kevin Miller at Solve 3D.
Kevin, in this video, we're going to talk about how to prepare, which is basically labeling data, training data, to train up a deep learning based model for identifying objects in panoramic imagery. Now, of course, panoramic imagery goes by a couple of different names, scene view or spherical imagery, or by maybe a couple of others. Um, I should point out that we're not going to go into a lot of the nuances of deep learning in this video. I recommend for everybody to go back to the LiDAR videos and the aerial classification videos to get some tips and tricks on deep learning that also apply here. But why don't we jump in and take us through how you prepare and set up your labeling for panoramic imagery.
Okay, so to start off, I'm just going to show you the workshop data that we have prepared here for this video. So we have a few folders, training data, again, all of those panoramics. These are our rectangular panoramics, meaning they're, just like any other viewer in here, they're, 2 times width as they are in height. So panos. And then along with each pano, we also have a CSV file that describes the location and orientation of each of those panels. So if you need help finding those data sets inside of your collection, please refer to our other generic engine user guide for tips on that. So we're going to load these into the engine viewer, which I have loaded. We can click add item and add panoramic CSV. And I'll go to that training data folder here and select that CSV file. This viewer will load pretty much most of the major sensors out there in data. If it doesn't load, please contact our support at help@solve.com, and you can send an email to that, and we can help you with any other sensors that you might be using. So we've loaded our panels. You can see here we have over 1,000 here. They're loaded in the aerial view. They are in the middle of the ocean, so let's fix that. We're going to go to the pencil again and change the projection. I know this is Colorado North, so I've already defined it and put it into my projection list. So I'm going to select it and update the project. If you didn't have it in your projection list, you can always go to Tools, Projection Manager, and add it in, search for it and add it in here. So now that we got our data loaded, see here it is. We can navigate around and look around our data and drive down the street. We're gonna, for the purpose of this workshop, we're gonna be interested in traffic lights. So things like these things at the top of these poles here. So what we do here for training, to open training, we go to Tools, Scene View Classification. So scene view is this 3D kind of panoramic view where you'd see your LiDAR and your panoramic pictures. Got the scene view classification tool loaded. So a couple differences between this tool and the aerial classification tool. They look very similar, but the major difference is that you only have to define objects that are within a specific panoramic. In the aerial view, you might be working with a big picture of your entire city. So you might want to define just a smaller training area for that you want to define a labels for. In this case, we are working with individual panoramics. So you got to make sure you label data that encompasses that entire panoramic. So I'll show you an example of that so hopefully it makes more sense in a second here. So I'm going to click Add Class and define one called Traffic Light. Hit Submit. And now it's just a matter of starting to label some of these. So we got some nice clear views of traffic lights here. So to start labeling these, we click the Add New Label button. And now we can start simply just clicking and drawing polygons around these things. So a couple things to note while I'm doing this. You can always hit space to start drawing a new one. And I'll just do a few of these really quickly here.
And as you're doing that, Kevin, I notice you're leaving a lot more space around the objects than we did in the aerial view. And I guess that's an important tip for people. When you're in the scene view classification, the deep learning tool needs a little bit more context than it does in the aerial view. So it's always good to include a little bit of boundary around the objects that you're labeling.
That's right. Yeah, adding some context is always important. The machine learns from those things. So again, also there's many different types of traffic lights. So I want to make sure I'm labeling all of the traffic lights that I see, at least ones that I'm considering are traffic lights. And you can see here, here's a little 5 light one versus these ones that we're labeling up above me. These are also important. Maybe even these ones too. I know this is a traffic light, even though it's facing the other direction. So I can label it too and give it the context that there might be a pole in front of it or whatever it may be in that case. So for the interest of time, I'm going to delete this set and import the ones that I've done previously. So you can always import and export these labels, for if you want to save them what you're doing, or you want to use them for later to enhance your training data. So under our workshop data, there's a training labels folder, and we have a traffic light 3DL file that I can just open. I'm going to leave this on the default settings, but I've labeled 74 traffic lights here. So we import them in. So here they all are. Some things to note here. You may notice that there's a traffic light way here in the distance. I chose not to label this in this case, mainly just because it's too small and kind of blurry in my image data set, but it is important to label everything that you consider a traffic light in your data set, just for sake of having completeness on the model, so it learns off of all those examples. Just quickly, I can navigate around. If I wanted to look at a few of these, click on them and view them. I can always edit them if I need to make changes and drag vertices and resize them. Or if I want to change my mind and delete one, I can always right click and just choose to delete it.
So in this view that we've got right here, I think it's also important to mention that this looks like it's another camera location with a different angle on those traffic lights. So as you mentioned early, you don't have to go through the entire project at every camera location and label all the traffic lights in the entire project. You just need to pick, a couple of different representative locations. And in this case, you've got a couple of different representative angles of what you're likely to see in your data set. Couple of different magnitudes. And as you say, you've got 3 light examples, you got 5 light examples. You've got some good representative data happening here.
That's right. Yeah, it's always important to get multiple perspectives of the same image. All right, so now that we've finished labeling, you can choose to do multiple classes if you need to. I'm for the purpose of this workshop, I'm just going to do traffic lights, but you can always define, as many classes as you need if you want to label poles and cracks in the road or whatever it might be. You can choose to create more labels and do the classification on those. So now we're going to run some training. So we click the Run Training button. And just like the aerial images, this is fairly quick. It really depends on how many labels you've defined and how many panels that you might have, but we're going to define the number of iterations. I'm going to leave this at 1,000, but again, if you have time to wait and you want it to be a little more accurate, increasing the number of iterations is always a good idea. I'm going to select a folder where I want my output. So we're going to put this under the My Results folder. This is where it's going to create the model. And if you were previously training, if you previously have done this and you've increased you have some more training data from a different location in the world, you may want to add to an existing model that you've created before just to give it more examples. So this is where you could select that existing model and add to it. We're just going to ignore that for now. So we're going to hit submit. And just like before, if this is the first time you've ran any machine learning using the engine toolset, it's going to automatically start downloading some ML resources for you. In this case, I've already done that, so it's already skipped ahead. and you can start seeing this progress bar here. And in a second here, a TensorBoard window, here it is, will load just like in the aerial view, showing your accuracy and any false negatives that you might have. So at the start here, isn't much data to show, so we'll just let it run for a little bit here.
And I'm assuming, Kevin, just like TensorBoard in LiDAR and aerial, you're going to have to update the graph by clicking on that third little icon there as the data starts to come in so you can see the results.
That's right, yeah. I'm just going to let it run for a few more percentages here. And I'll just force it to refresh and see what we're getting at here. There we go. So yeah, clicking that third icon again to resize or rescale the graph to show the data. So we're hovering around 81% now. We've only done about 55 iterations, so we're going up to 1,000 here. We'll wait for it to get to 1,000.
Okay, we're almost done here. Yep, looks like we're done.
Great, so I'm just going to leave this running for a bit, just to show you what you might come back to if you walked away from your computer. So since the process is done, the machine has finished learning everything it needs to know over these 1,000 iterations. This TensorBoard window, once it refreshes here, is probably going to give you a message like this saying that it's down, can't be accessed anymore. And you note there's a log directory here. This is where it's saved some information about the model that it's just trained. So if you see this message, this is normal, don't be worried about it. You can simply close this. If you want to see the results on the graph of your model, how well it did, you can always open the regular engine. Just do that quickly. Search for the word model here under the object classification module section. You can just search for model and select the view model stats function. And I can select that same folder that was mentioned there. So in my case, under Pano, my results, this is the folder, and hit execute and confirm my workflow. And in a few seconds here, it'll just spin up that TensorBoard again and show us the graph of the model in its final stages here.
And there are the results. Those are pretty good results. I mean, that's what, 97%,
97, 95, yeah.
Yeah, something like that, accuracy.
So I'll just exit that.
Okay, and now we have a model that's been trained up. We reviewed our results, and now we will move on to showing people how to actually use that model to identify objects in their data.
Sounds good.
Here are the key takeaways from this video. First, when you're labeling your example objects, make sure you include some of the surrounding image just to give the algorithm some context for your example objects. Second, you can save your labeling as you go and re-import it at any time. This can be a great time saver if you're updating a training model or if you've got a lot of objects that you need to label. You do not need to label your example objects in every camera location, in other words, every image, but you do need to label all of your example objects if you label any given image. You should also label your example objects from as many different viewpoints and as many different sizes as you can. Finally, try different settings for the iterations to see which works best for you.